In today's video, we're going to prove that a quadrilateral is a parallelogram. And we're going to do it off the coordinate plane, and then we're going to do a two-column proof. So let's take a look at some different ways that we can prove that a quadrilateral is a parallelogram. One is that both pairs of opposite sides are parallel. Another is that both pairs of opposite sides are congruent. All right, that should be number 3, that the same pair of opposite sides are both parallel and congruent. All right, both pairs of opposite angles are congruent in the parallelogram. All right, or it is a parallelogram then. And then a quadrilateral with diagonals that bisect each other is also going to prove that you have a parallelogram. Okay, let's look at example number 1. It says given quadrilateral ABCD, A is 3, 4, B is -1, 3, C is -4, -2, and D is 0, -1. It says prove that quadrilateral ABCD is a parallelogram. Well, I've plotted it already because I didn't want to waste your time and you seeing me plot the points. So, some different approaches here. One thing we should know that, especially on a coordinate plane, is that if we have line segments in which the slopes of the line segments are congruent, then we know that the lines are parallel. So if I can find that, then I know I can find that I have two pairs of parallel lines or line segments. Now, one approach that you can take is that you can plug these points into your slope formula. Well, your slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, the change of y over the change of x. But I'm not going to do that. I'm going to use a grid, and I'm going to calculate by counting. So the first one that I'm going to look at, or the first line segment, is line segment AB. And I'm going to count. My rise is 1, and my run is 4. So my slope of AB is 1 over 4. I'm going to look at the opposite side. The slope of line segment CD. All right. That equals, well, my rise is -1, and then my run is -4. So that equals -1 over -4. And we know that equals 1/4. All right, let's look at the slope of CB. Okay, so CB, I'm going to count. All right, so if I count that, my rise is going to be 5, and my run is going to be 3. Okay, and the last one is the slope of AD. So my rise here is going to be negative. All right, so that's -5. And then my run is -3. So that equals -5 over -3, which equals 5/3. So what I might want to do, nice, is I might want to point out that that is from the graph. And if I now have two sides in which the line segments are parallel, so I have a parallelogram. So I can write my concluding statement. So segments with the same slope are parallel. So AB is perpendicular to CD. And BC is parallel to AD. So AB is parallel to CD and BC is parallel to AD. So AB, or line segment quadrilateral ABCD has both pairs of opposite sides parallel, making a parallelogram. And I'm going to do the symbol, and you can too. All right, so that's the first proof. Let's take a look at number 2. All right, number 2. It says given triangle LGS is congruent to triangle HAF. I have my highlighter out already, so I'm going to do that. So LGS is congruent to HAF. All right, so that's given to me already, and what I have to do is I have to prove that FLHS is a parallelogram. All right, now this one is not that bad. So I have my statements and reasons set up. So let me get back to pen. All right, and while you're setting up your statements or reasons, or you're getting ready to flow it out, whichever you prefer. All right, so my first statement and my 2-column proof is going to be my given. The triangle LGS is congruent to triangle HAF, and that is given. All right, number 2, what I'm going to do is because of that, I can say that LS, all right, is congruent, line segment LS is congruent to line segment HF. I'm going to do that. And the reason for that is CPCTC. Now I'm going to put angle 1 here, and then angle 2. And I know immediately you're thinking, oh, alternate interior angles. Well, they are. And guess what? They're congruent. And they're congruent because of CPCTC. They're both part of that triangle. And they are corresponding angles of those 2 triangles. So number 3, angle 1 is congruent to angle 2. And that reason is CPCTC. Now I can say that LS, line segment LS, is parallel to line segment FH. And the reason for that is that I have congruent alternate interior angles. That means I have parallel lines. So congruent alternate interior, abbreviate, angles. Okay, congruent, that means I have, again, parallel lines. All right, and the last one, I can say FLHS is a parallelogram. And the reason? Quad same side, parallel, and congruent is a parallelogram. Not bad. All right. So, of course, what I want you to do is write down some key ideas and please attack or go right at that, check your understanding. All right. And I will check that tomorrow. We'll talk more about these concepts tomorrow. And remember, go Cats, go Knights.